Okay, this is section 6.5 where we're going to learn about similarity and measurement. So all of that stuff we learned in the last couple of chapters about similar triangles and quadrilaterals, we're going to learn how we can actually apply it in those property we learned. So I have 4 examples for you today. We're going to have to test out your drawing skills because we've got a bunch of figures to draw. Okay, for the first one. I'm gonna give you a figure and a relationship, and we want to find the unknown side. So for the first one, I'm gonna tell you that we have triangle STU, and it is similar to triangle DEF. And what we want to do is we want to find DF. All right, now time for the drawing. We've got our first triangle STU. Once again, make sure you're labeling it the same way I am. And then on the other side, we've got triangle DEF. Okay, and we're going to be given just a couple of the side lengths. TU is going to measure 45 millimeters. SU measures 35 millimeters. EF measures 36 meters, and DF measures X. I think I was saying millimeters earlier, but we're going to stick with meters for all of them. Okay, now remember this the property we learned in the last chapter that says the similar figures, the ratio of their corresponding sides are equal. So what I can do, just like before, I can set up the ratio of the corresponding sides, and I can make a proportion. So if we start with, let's say, triangle STU to triangle DEF, so we're going to put all of the side lengths of STU in the numerator and all of the side lengths of DEF in the denominator. So let's start with side SU. Okay, we need to find its corresponding side in my other triangle. Now remember, SU, we need to look where those letters fall. So it's the first and the last letter in my name. So I'm looking for the first and the last letter in my other triangle. So SU corresponds to DF. Okay, we're going to set that equal to, because we're going to form a proportion to my other side. And we're going to look for TU. Once again, STU, we're going to have to put it in the numerator and DEF in the denominator. We've got to stay consistent with that. Okay, and TU are the last 2 letters, and EF are the last 2 letters in my second triangle. So now we're going to fill in those blanks. So SU measures 35. DF measures X. That's the side we're looking for. TU measures 45, and EF measures 36. Okay, so we could go right ahead and we could cross multiply and take 36 times 35 and X times 45. Okay, but I don't know about you, I'm not really ready to take 36 times 35. Let's see if we can make our life easier. So remember, we can look and we can reduce any of our fractions. And I see that 45 and 36, I know that I can divide out a 9 from both of those numbers. So I'm going to rewrite my proportion, but I'm going to simplify that ratio on the right-hand side. 45 divided by 9 gives me 5. 36 divided by 9 gives me 4. Now I can take 35 times 4. And 35 times 4 gives me 140. X times 5 gives me 5x. And if I want to solve for x, I'm going to divide both sides by 5. So x equals 28 meters, complete with a unit. Okay, let's look at another example. This time, let's look at a quadrilateral. So I'm going to give you that JKLM is similar to PQRS, and this time we want to find PQ. Okay, so we're going to have a parallelogram. I know we haven't talked exactly what a parallelogram is, but it should look something like that. And this first one is going to be JKLM. And then we're going to have our other parallelogram off to the right. And this one is PQRS. Okay, and the information we're given, JM measures 21 inches. JK measures 36 inches. SP measures 35 inches. And PQ, which is what we're looking for, we're going to label that with an X. Okay, so I want you guys to pause the video, and I just want you to set up the corresponding sides relationship that we need in order to set up a ratio. Then go ahead and play the video. Make sure you set them up right before you move on. Okay, your proportion didn't have to look exactly like this. For instance, if you decided to put PQ and PS in the numerator, that's fine, but both the PQ and PS needed to be in the numerator, and the JK and the JM needed to be in the denominator. Also, if you decided instead to maybe put KJ, that would have been fine, or MJ, that would have been fine as well. But the relationship should look very similar to this. Okay, we're going to go ahead and replace our side lengths with the actual length. So JK, I know, measures 36 inches. PQ is what we're looking for, so we're going to put that down as an X. JM measures 21, and PS measures 35. Okay, I want you guys to go ahead and solve this solve this proportion. Once again, remember, maybe you can divide something out of one of your ratios to make your life easier. So go ahead and pause the video and solve this proportion. Whether you reduced or not, you should have ended up with X equals 60 inches. If not, go ahead and check your work, see what you did differently, and try to correct it. Okay, I'm going to let you guys try this next one all on your own. So as soon as I get the problem set up, I want you guys to go ahead and pause the video and try to get it worked out all on your own. Okay, this time we're talking about quadrilateral KLMN. I'm going to say it is similar to PQRS, and this time we want to find SR. Okay, this time we're going to deal with rectangles. So let's draw our first smaller rectangle. That is KLMN, and the second one's going to be a larger rectangle. And that one is PQRS. Okay, KN measures 2 centimeters. NM measures 3 centimeters. PS measures 3 centimeters, and SR measures X. Okay, so go ahead and pause the video, set up your proportion, and then go ahead and solve for X. Alright, you should have ended up with X equals 4 1/2 centimeters. Okay, this last one's going to be just a little bit different, so we're going to work this one out together. This one we're going to have to use a little bit more thinking to do. Okay, so our given information is going to be given triangle GHJ is similar to triangle GKL. Okay, it's going to be very, very important to refer back to those letters. Like I said, this one's going to be a little bit trickier. Okay, so this time we're going to have a big triangle, and then we're going to have a little triangle inside the big triangle, okay? So we're going to have GKL and JH. Make sure you get those all labeled the same. Okay, we're going to have KL measures 21 meters. KH measures 20 meters. JH measures 7 meters. And HG is what we're looking for. Forgot to add that up there. We're looking for HG. Okay, now this time it might be a little tricky to decide what your proportion might look like. So what I like to do is I like to start out with some sides that I do know. For instance, I know what LK measures, so that's probably going to be one of my corresponding sides I'm going to use. So if I know LK's measure, I'm going to look for the corresponding side from my other one. Now I notice this time that KL is in my second triangle. So KL corresponds to HJ. Now, you have to be really careful. Since I started with KL and it was on the right-hand side, whenever I set up the other half of my proportion, the side lengths from GKL have got to go in the numerator. Remember, we have to stay consistent with that. Okay, now if we think about this, I know that I am looking for this measure here, which is the bottom of my smaller triangle. Now, I don't know the bottom of my larger triangle, but maybe I can represent it using these two pieces of information, and we'll get to that here in a second. So we're going to set up our other half of our proportion using the bottom of our triangles. So remember, if the numerator was for G, K, L, that has to go in my numerator. So KG is going to be my numerator, and I'm looking for my corresponding side. KG are my first two letters, so its corresponding side is going to be GH. Okay, so let's go ahead and replace our values with the numbers that we know. I know LK measures 21, HJ measures 7. Okay, I don't know what KG measures, but let's go ahead and come back to that because GH, I know that it's X. Okay, I don't know what KG measures, but I know that KH measures 20 and HG measures X. So if I add those two together, that will tell me what the length of the whole side is. Now that I have my proportion, it looks just a little bit different. We can still use cross products to solve this proportion. So if we decide to simplify, because we always like to make life easier, I notice here 21 over 7, I can divide out a 7 from both of those. So instead this turns into 3 over 1 equals 20 plus x over x. Okay, I know we haven't done cross products that look like this, but you work them out the exact same way. You're still going to multiply up and across and set them equal to each other. Okay, and I know that 1 times 20 plus x, this is where you have to be really careful since I'm taking 1 times a quantity. You have to go ahead and put those parentheses. In this case, it's not going to matter a whole lot because I know 1 times anything is itself, so it's just going to turn into 3x equals 20 plus x. It's been a while since we've solved equations like this. I have x's on both sides of my equal sign, so the first thing I need to do is get them all in one place. So I'm going to subtract x from both sides. I get 2x equals 20. I'm going to divide both sides by 2, so I get x equals 10 meters. And let's just double check and make sure that was what I was looking to find. I got x equals 10 meters, and I was asked to find hg. And I noticed that hg is x, so I found what I was looking for, so my answer 10 meters is correct.